All right, folks, it's Bass Action, back in action here. In this video, we are going to go over various function operations. This is in no way going to be exhaustive of all the function operations that can happen, but we'll cover some of the common errors that you'll see. And also we'll present some little elements of things that we're going to see in later problems in this semester and chapter actually. So let's just take a note up here at the top. I've got three different functions that I've given you, an f of x, a g of x, and an m of x. And throughout the next 6 examples, we're going to work with each of these. And so it's important that you pay attention to what particular function the problem is talking about. So let's just jump into A here. A is really, really simple, but does have some elements that we want to pay attention to. We want to first look at the f of x function, and it's specifically telling us to take everywhere we see an x and we're going to replace it with this negative x. So when I jump into this problem and I start writing this out, what I'm going to do is everywhere that I see x, so both here and here, I'm going to replace that with a negative x. And in the denominator, I'm going to put a negative x minus then a 3. So the negative 3 is going to stay the same. Now, what's important to notice here is that we have a leading coefficient of negative. Okay, so since my leading coefficient is negative, what I can actually do here in the denominator is I can factor out that negative, and I'll get an x plus 3. And when I put that under the negative x, now I can see that these x's or these negatives would cancel with each other. So a fully simplified answer would be x over x plus 3. So yes, these two, I would accept that one, but these are actually both equivalent, and this is probably our better and cleaner answer that we would want to look for. Now on the next one is this f of x f of 2x plus 3. Sorry about that. And what we're going to do is we're going to take 2x plus 3, that entire expression, and we're going to again replace it in both places for x in that function. So the numerator is now going to become a full 2x plus 3. And then in the denominator, I'm going to have a 2x plus 3. And I'm going to write it in a different color to make it kind of stand out. That original minus 3 is still going to be there. So we want to make sure that that remains. Now, when we do that, we can see that these two values are going to cancel each other out. So our f of 2x plus 3 is going to become 2x plus 3 all over a 2x. So that's going to be that final answer there. Just give you a little heads up, a common error that students make on this is they replace the 2x plus 3 in the numerator and then they forget this one in the denominator. On the next one, what we are going to do is we're going to subtract two functions. So we're going to take the original f function, and the original f function, you still have it on your paper, pretty visible there, was an x over the x minus 3. And we're going to subtract the m of x function, and m of x is 1 over 3x plus 1. Now, when we subtract these, this is a good review of how we subtract rational expressions. And a tip that I would give you is I would take this negative and I would flip it to a positive, and then I would move that negative up to the numerator. That's just going to be a little easier for you, help you not lose track of it. We're going to need to get common denominators. So I'm going to multiply the first expression by a 3x plus 1 and a 3 over 3x plus 1. The second expression is going to get multiplied by x minus 3 over x minus 3. Now, in the numerator, the new numerator is going to become 3x squared plus an x, and then the other part of that numerator is going to be this product. So I'm going to distribute that negative 1, and it's going to become minus x plus 3. And that's all over what is now this new common denominator that I've got here. And I actually do not need to multiply that out. Students often go to that exercise of multiplying that out because you guys are used to foiling, but it's actually not necessary. We can see that our x's here, our linear terms, actually cancel each other out now. So our final answer on this problem would be 3x squared plus 3 all over 3x plus 1 times x minus 3. And again, you do not actually need to multiply that out. So that would be that final answer. It does not equal 0. It doesn't equal anything right now. It's just a new function that we're creating. This next one is going to look exceptionally weird, and you got to be really careful when you write that h, but I'm going to tell you, put a little star on this one. This is going to become a really important expression for us to be able to do, and for those of you going on to calculus, it's going to be really, really important for you as well. So some of you, it's just kind of a short-term importance, and some of you, it's definitely long-term. What we're going to do is we're going to put the x of h into the g function, just like we did the 2x plus 3 in the problem above. So the first thing I'm going to do is I'm going to take my g function. You've got it up above. The g function is 9x squared minus 1. So that's going to become 9, and this is going to become x plus h. I always have to be careful that mine doesn't end up looking like some other number. Squared, and then I still have the minus 1. So this piece here is now this piece, and then I'm going to subtract, that's this subtraction right there, and I'm going to subtract this whole original g function. Now, this parentheses that I'm doing here is also a common mistake. It's something that students often lose. So in the next step, we're going to FOIL this 9 or this x plus h squared. So I'm still going to have a 9 is a coefficient, and I'm going to have an x squared. It's going to become 2xh plus h squared. And that parentheses, I'll still have a minus 1. And now I'm going to distribute this negative. So it's going to become minus 9x squared plus 1. Okay? You got to be really careful in writing your steps here. At this point, I can distribute my 9 to this entire expression here. So this will become 9x squared plus 18xh plus 9h squared. And then I, of course, still have minus 1 minus 9x squared plus 1. At this point, a whole bunch of things should cancel in this expression. We can see the 9x squares are going to cancel. The plus minus 1 and the plus 1 are going to cancel. So we are simply left with 18xh plus 9h squared. And that's all you need to do with that, and you're done there. All right, 2 more we're going to take a look at. Again, I'm just trying to give you a good compare and contrast, including some common errors. These 2 problems are here because this filled in dot is often confused with this open circle that I have here. This dot here means to multiply the 2 expressions and create two functions and create a new function. This open circle here is our function composition notation, and it means that we're going to find a new function that's m of g of x. So make sure that you're looking carefully at those 2 different expressions and notations. Okay, we're going to take our m and our g functions this time. On E, we're going to take the m function, and the m function is 1 over 3x plus 1. I'm going to go ahead and put that in parentheses. And then the g function was that 9x squared minus 1. And since my m function was a fraction, I'm going to write the g function as a fraction as well. Now, what you want to really get in the habit of looking for here, give yourself a little star, is looking for places that things could potentially factor. So this numerator of 9x squared minus 1 is a difference of squares, and it's going to factor into 3x minus 1 and a 3x plus 1. That's, of course, still all over this 3x plus 1, because remember, when we multiply, we're just going to go straight across, okay? At this point, now some things are going to cancel. These 3x plus 1s are going to cancel, and I'm left with a very simple looking function of 3x minus 1. So if you type this whole thing right here into Desmos, what you're going to do is you're going to get an equation for just a line, because Desmos knows that these 2 pieces are going to cancel. Now, the reason I've included this one here is what I want to draw your attention to is that, again, in Desmos, if you actually click on the value of -1/3, what you're going to find is it's going to tell you that it's undefined. And it's going to be undefined because this 3x plus 1 canceled. When we would find the domain for this new function, our domain would consider any restrictions that these functions right here had. So this is what it'll graph, but the domain is based on the original expression or function that we had. So this domain would actually be our x such that x is not equal to a -1/3 because that -1/3 would have made the original function 0 in the denominator. Now, on our function composition, we're going to take a look at that one, and that means that we're going to start with this outer function first. I like to always write the outer function. Our outer function in this case is m of x, and m of x in this case was our 1/3x plus 1. And now what we want to do is we want to replace the x in this with the g of x function. So I'm going to have 1/3, and then that x is going to become the g of x function, which was 9x squared minus 1. Don't forget, we need to include, when we're writing this, we need to include this original plus 1 right here. So we're going to go ahead and include this nice plus 1 right there. Now from here, we're going to do a little bit of expanding. And when we do that, we're going to end up with 27x squared, just distributing this 3, and I'm going to distribute the 3 again, minus 3 plus 1. So my new function becomes 27x squared minus 2. Now, when I do that, and this is going to be that final answer, and this looks just fine. When we find the domain for this composed function, just like that last problem, I want to consider any restrictions from this inner function. Okay, so I'm going to look at my inner function here, and I'd say, oh, does my g of x function have any restrictions? And I would say no, because it's a parabola. But then I would also look at any domain restrictions from this final answer here, and that one's going to require a little bit of work. We're going to take this 27x squared. I'm setting it equal to 0. So 27x squared equals 2. I'm dividing by 27. So I'm going to have x squared equals 2 over 27. Now I'm going to do a square root, and a square root. And I end up with plus or minus 2 over 3 radical 3. And when I get that, or square root of 2, sorry, I lost my square root of 2 there. Square root of 2 over 3 radical 3, and then I'm going to do a quick rationalizing. So this is a really, really gross looking answer, but I want you guys to be able to do this. So this is going to be x such that x is not equal to a plus or minus square root of 6 all over 9. And if you've lost that, it's the radical 2 times the radical 3, and then 3 radical 3 times my radical 3 gave me my 9. Okay, so just kind of maybe put a star on this because we're going to come back to this domain of our composed functions quite a bit. And that's all that we have on the basics of function operations.